2013, we apparently ran across much of a crocodile. So here's a couple of vertebrae
Of a crocodile
of a crocodile
that lived.
that lived in this swamp 50 million years ago.
The fossil collection in Dr. Robert Anemone's office is more than just proof of life at the start of the Eocene epoch in what is now the American West. It is a snapshot of time. 50 million years ago, the dinosaurs had disappeared. The Rocky Mountains were rising. Prehistoric mammals were adapting and spreading.
And again, there was a lake in this basin. There were rivers draining into the lake. So animals, some of the animals that we're finding were living mostly in the lake, or along the shores of the lake, or on the streams that were coming into it.
Wyoming's Great Divide Basin is in the southwest part of the state, in between chains of the Rocky Mountains. The area straddles the Continental Divide. It is an arid landscape now, but at the start of the Eocene, the land was underwater.
So again, the carapace of a turtle. Again, turtles are living out, along these swamps. We've got alligators also. So again, the dermal bones or the skin bones of an alligator, or scutes they're called.
The skin bones.
Yeah. It's kind of an external kind of skeleton.
Senior biology student Ashley Bryant found some of the tiny fossil treasures.
But I remember when I found my first jaw, it's like the heavens opened up and it was just laying right there on the ground. And I picked it up and I'm like, teeth in a jaw. So it was amazing.
I did it.
I did it. Jaws with teeth in them are the absolute best. Teeth, period, are good because you're able to know what that animal ate just from looking at their jaws. You can see what muscles articulated where, and from using that you can say, look at a past fossil that you found and see the difference in how that mammal has progressed, how that mammal has evolved.
And this fossil hunting story could end there, with a successful expedition producing a rich collection of fossils. But it doesn't.
Paleontologists have been working in the field in pretty much similar ways for the last 100 or more years. We go to places where the geologists tell us the rocks are of the right age and they're exposed, and maybe there's some erosion on the surface. And we try to get out into these deposits, and then we survey and we look for fossils eroding right out of the surface. Well, we found lots of fossils with this technique over the years, but in very large basins like the one that I work in, which is 10,000 square kilometers in area, it's perhaps not the most efficient way.
This is just the start of the story, because one night, gazing at the stars in the dark Wyoming sky, Dr. Anemone found inspiration for a better way to find fossils.
There's a sensor in the Landsat satellite which is capturing the intensity of the reflected radiation from the Earth's surface back up into space.
That's right, satellites. The Landsat program launched in 1972. It is the world's longest-running Earth imaging program. Landsat satellites image the Earth in various wavelengths of light, bouncing off the surface. Soil and earth features are in one wavelength, vegetation in another, water in still another. There are 8 images in all, and those images are combined to form a complete picture. Dr. Anemone worked with other scientists to develop a computer model to analyze satellite images of the basin. The program compares known fossil locations with prospective dig sites. If the spectral signatures of both sites match, meaning soil type, chemical composition, ground cover, and other features are the same, the program predicts there's a high probability fossils could be found there.
So the satellite is able to distinguish between these different kinds of land covers, we call them. And it can be trained then to recognize and look for other things that resemble any one of them. And the one that we obviously look at are the known localities, and let's find other ones that resemble those.
The red markings on the satellite image indicate predicted fossil sites. To test the model, Dr. Anemone and his team went to 31 places the computer model indicated fossils may be found in.
The yellow shows a trace of a day's work, and the green are places where we found fossils.
25 of those did yield vertebrate fossils.
And within an hour, we found our first Eocene mammals from just following this predictive map. And it was a eureka moment. It was the first moment when we said, this stuff really might work.
Finding fossils, I learned, is an experience where you have to have patience. Because at a certain point, you get to where it's like everything looks the same. I don't know if this is a rock or if this is a tooth. But once you find that tooth, once you find that bone, it makes it all worth it.
Dr. Anemone continues refining his satellite fossil finding system, and he admits it will take time for paleontologists to accept the idea. Tradition, after all, is difficult to challenge. But he says even with the help of technology, paleontology is still painstakingly hard work.
What I can say to those colleagues and other paleontologists is that we still do the hard work in the field of walking long distances with our eyes, on the ground, bent over at the waist. But I think we're doing it in a more efficient fashion now than the way we used to do it.